In this video, we'll learn how to chain lambdas. Now, Java is an object-oriented programming, but with the introduction of lambda expressions, now we have some aspects of the functional programming paradigm. Now, let's see how we can chain up multiple lambda expressions. Now, let's say I have two consumers. So, let's say consumer of string C1. So, the first one, let's say it takes a string as parameter and just prints something. So, consumer 1, and it will just print the string. And I have another consumer, it also takes a string as parameter and just prints it. And now what I want to do is create another consumer. Let's name it C3. It takes a string as a parameter, and then it uses C1 and C2, both these consumers. So first it will call C1.accept as, and then it will call C2.accept as. And now let's say I take a dummy string as is equal to hello world, and then invoke the c3.accept method. Then it is going to first invoke the c1.accept method and then c2.accept method. Now c3 is actually invoking the right methods from the right consumer, but there is actually another way of doing this. What we can write is something like this. So consumer string c3 is equal to c1 dot and then c2. So what it does, whenever we pass a string to this consumer C3, it first has to go through 1 and then it goes through 2. And now if I try to run this, we'll end up getting the same output. And this is how we are chaining two consumers or two lambda expressions. Now if you look closely, we are invoking this and then method, right? And where are we invoking this from? We are invoking this from this consumer, which is a functional interface. So it means that since it is a functional interface, it has to be something apart from an abstract method. As you can see, it is indeed a default method. And now, what does this and then method do? It takes in a consumer, and what does it do next? It invokes the accept method that it has within itself. After that, it invokes the accept method from the consumer that was passed into it, right? So this part is exactly what we did earlier. And what does it return? As you can see, it returns the consumer, right? Since it is returning the consumer, they've used a lambda expression to return it. Now let's try to see another example. So if you remember from our previous video, we had a student class. A student had a name and had an ID. So let's say I want to create a predicate for a student that verifies if the name of a student starts with the character A and his or her ID is even. So first, let's create a predicate for the name. So predicate takes a string. Okay, so predicate takes a student, and let's say the name of the predicate is name starts with A. So it takes a student s, and it will return s dot get name dot starts with, let's say, A. Now to the next predicate, which takes a student, age is even. So it takes in a student, and s dot get age, get ID mod 2 has to be 0. Now we'll try to combine these two predicates. So let's say predicate student custom predicate is name starts with A dot end age is even, right? And now let's test this out. Let's say I have a student, S1 is new student, and let's say the name starts with A, the ID is an even number, and then s out s1 dot custom pred dot test s1. Now it should return true since it starts with A and has an even ID, and indeed it is true. Let's give it 9, so it should return false, or let's give it an even ID but the name starts with B, so it should also return false. Now if you look closely, for consumers, the method that we were using was and then, but for predicate we are using this dot and method. Now if you go into this predicate class, then you will not find any method named and then, but you can probably guess why we are using this dot and method, or as to why this predicate has a dot and method. So we know predicate returns boolean, right? So since it is returning boolean, a predicate must have methods that support the binary operations, for example dot n, right? So we can chain up these lambda expressions and use this in various situations. For example, let's say we have a list, and this is a list of students. So we want to sort this list. So what we could do is first sort this list by their names, then sort this list by their IDs, and then we can compose these two comparators and compare by their names and then by their ID. So this is how it should look. So if let's say I have a list, so I first created a comparator for name, which compares the names of two students, and then a comparator for age. It compares the ID for the students. Then for the custom comparator, the student has to first go through the name comparator, and then if it matches, if two names are same, only then will this age comparator come into play. So just to make sure, if you look into the implementation of this then comparing method, you can see it only invokes this other comparator only when two entities are the same. Otherwise, it returns the result.